All right. Now, let us just talk about linear equations in two variables, right? So just give me any one linear equation in two variables of your choice.
4x plus 5y.
That's 5y equals to,
5.
okay, is equals to 5. So this is a linear equation that I have got, right? This red equation, a red line that I've got. Since
Yeah.
it's a line, right? The graph of this uh, polynomial is a line. So that is why the name that comes is a linear polynomial. Okay.
Yeah.
Now, in this scenario, there is an infinite number of solutions that are possible for this polynomial, isn't it?
Yeah.
Right. How, if you just plot some points, like this is one of the points, 0 comma 1 also satisfies this. 1.5 1.25 comma 0 also satisfies this equation, isn't it?
Yeah. So these are basically all values of x and y that are basically the points that derive to this line.
Yeah, so they actually form, when you just join all these points together, they'll form this line, and this is a never ending line. You can see,
Yeah.
right? So there's an arrow at both the ends because it's a never ending line, and it has infinitely many solutions, right?
Yeah.
Now just consider it this way, that I am actually putting a condition on x and y, that 4 times of x when added to 5 times of y should give 5, right? So
Okay.
this condition can be satisfied by a lot of pairs, a lot of ordered pairs. That is why it has infinitely many solutions.
Yeah.
Okay. Now if I say simultaneously I also want that twice of x minus 6 times of y should be 9. Okay.
Yeah.
So I have now posed another condition on x and y, that
Yeah.
6 times y when subtracted from twice of x should be 9. There's another condition that I have posed. So this actually gives you a pair of linear equations in two variables, and this simultaneously is called a system of linear equations in two variables. Okay. Now there are this entire blue line when looked in isolation. There are again infinite points which will satisfy this line, isn't it?
Yeah.
This condition is satisfied by many points. So one of them can be this: when it cuts the x-axis, it cuts it at 4.5 comma 0. One point is 0 comma minus 1.5. There are a different number of ordered pairs again which can satisfy this condition. But when I actually place both of them together, right, then
Yeah.
how many points will satisfy both of them simultaneously?
Only one.
Only one. And this happens to be, graphically I've observed, it is 2.206 and minus 0.765. Is it okay?
Yeah.
And this point is such a point which actually is giving satisfaction to the blue line also and red line, and simultaneously it is actually a solution for this pair of linear equations, or this system of linear equations. So this is actually a solution for this system of linear equations. Is it clear?
Yeah.
Okay. Now, in another sense, if I just give you another thing, right? So if I simply say 8x plus 10y is equals to 10, what has happened?
I'm sorry, what your voice was breaking.
Now see, I've given you another equation. 8x plus 10y is equals to 10.
Yeah.
Do you see this green line?
Yeah.
Okay. And where is the red line? Do you see this? Something?
Yeah. They are exactly the same. They are coincident.
Yeah, they are coincident lines. So in this system of linear equations, actually, what have you done? I have simply doubled this entire equation. I've simply multiplied the LHS and RHS by 2. Do you see this?
Yeah.
So the coefficients of x, y, and the constant term 5, both all these three things have been multiplied by a factor. They've been by a scale factor,
Yeah.
and they have actually given you coincident lines. So when I talk about these two lines,
Yeah.
So how many solutions do they have?
Infinite many.
Yeah, so this together, both of them have infinite many solutions. Again, there are many ordered pairs of x and y which can simultaneously satisfy both of them because they are actually having the same set of points which are making them a line, isn't
So
it?
basically, A1 upon A2 is equal to B1 upon B2 is equal to C1 upon C2.
Absolutely. And in this case, that constant factor, a1 upon a2, b1 upon b2, is actually 1
Is
by
half.
2, is half, right?
Yeah.
Okay. And in this case, in the same thing, if I just don't do it 10, but I do it 1,
Yeah.
so what has
So the
happened?
parallel, because A1 upon A2 is equals to B1 upon B2 is not equal to C1 upon C2.
Yes. So in this case, will there be any common solution between both of them?
No, they'll just keep on stretching along each other.
Yeah. So they are said to have no solution at all, isn't it?
Yeah.
Okay. So this way we have studied the consistency conditions